It's a jumble out there. Your office is home to miracles of efficient communication, the very staples of a productive workplace. Office Wonders, next on Modern Marvels. This office is a model of efficiency. Built just a few days ago, but older than history. Workers visit cubicles. Quotas are met. Productivity is high. The place is literally buzzing. Look closer. Worker bees, drones, desk jockeys, pencil pushers, paper shufflers, computer nerds, office geeks. They punch keys, juggle schedules, slash budgets, hack computers, wrestle paper tigers. Who says a day at the office isn't exciting? It's a hive of activity, the office. Over 130 million of America's busy bees spend an average of over 39 hours a week there. They consume nearly 100 million tons of paper a year and spend billions of dollars on equipment annually. Look even closer. Ever notice that this seemingly humble office is ground zero for the technology explosion? It has been for the past 150 years. Computers, telephones, fax machines, copiers, even Scotch tape. It all begins with a marvel so simple, so basic, so thin, that it's easy to overlook. Without it, there would be no office. The whole thing is supported by a sheet of paper.
Paper was invented in China in 200 BC. It went to Korea in 600, Japan 700, and then it went across the top of Africa, and then Europe, and it arrived in 1259, in the United States in 1690.
Paper was a big deal because of what it was not cumbersome, nor heavy, nor hard to store, nor short-lived. Before paper, people wrote on all sorts of things.
They would write on cuneiform nails, which were clay nails that they would put in the sides of buildings. In Thailand, they would use palm leaves. The most popular pre-paper was pounded bark.
It's hard to shove stone tablets into a file cabinet or alphabetize palm leaves, but reams of paper can be stored in very small areas. Paper can be collated, sorted, filed. Plus, paper is easy to produce. Start by beating down some wood fibers or cotton blue jeans into a pulp in a big vat.
But what we have right here is our mold and our decal. And we take our mold and decal together like this, and you bring it down into your vat. And you shake slightly as it's coming up. And the water will filter through. We remove the decal.
The decal is a type of frame which shapes the paper material onto the mold.
Place a blotter down. Put that right on there. What we are doing is adhering the paper to the blotter. And we'll continue this process. We'll keep putting blotters down.
It's quicker when it's done at a paper mill, which uses wood pulp to produce massive reams of paper for all sorts of uses, including product labels, fine writing tablets, even those hospital nightgowns with the embarrassing flaps. The earliest paper makers saw an advantage in diversifying.
The first colored paper was in China in about 600 AD. It was a yellow paper, and it was actually covered with a poisonous solution for an insecticide.
Envelopes began in Korea in 600 AD. Monks used lined paper in the Middle Ages to keep their calligraphy straight. People made paper out of fishing nets, blue jeans, cotton, straw, corn husks, practically anything that could be pounded flat. And with paper comes a host of other office wonders that are as simple as they are essential. Pencils can trace their lineage to the Roman stylus, a thin rod often made of lead. Graphite, the softest of solid minerals and the purest form of carbon after diamonds, ultimately replaced lead because it made a darker mark and was non-toxic. But it was too soft, so people hollowed out strips of wood and shoved in graphite sticks. By the early 19th century, companies began manufacturing wooden pencils on a large scale. Most pencils today are made of incense cedar. The number 2 is a measure of the hardness of the writing core. The familiar Ticonderoga pencil was painted yellow to indicate it used superior graphite from China. The pencil is an office mainstay, with 2 billion sold worldwide each year, all capable of writing 45,000 words. In addition to pencils, pens, often made from the flight feathers of geese dipped in ink, helped people get their ideas across. Ink could be made from berries, water, oil, soot, squid, though it too was being mass-produced by the 19th century. Markers and highlighters also contribute to the over 8 billion writing instruments purchased worldwide each year, at a cost of over $2 billion.
In 1963, a group of our lab people in Cambridge, Massachusetts at the Carter's Ink Company had been working on children's products when they took a children's marker and wrote over text that they could see the text through the line that they had written, and thus was born the highlighter.
The first highlighters were yellow. Today you can get them in nearly any color. Highlighters do more than just emphasize copy.
We find a lot of different uses that people have used the products for over the years. Anything from doing artwork to decorating their skin. Unfortunately, sometimes people also use permanent marker on their skin, and we have to help them in correcting those bad product decisions.
With all these papers flying around, devices were needed to sort them out. In the 1890s, people started bending pieces of wire and patenting them. The gem-style paperclip, the most successful but not the only paper fastener, was born. In 1914, the Boston Wire Stitcher Company introduced a desk-sized stapler that sent a small, sharp wire into a stack of papers, or the occasional finger. In 1903, the Clipper Manufacturing Company began producing metal clasps. There were other ways to collect paper: notebooks, index cards, file folders, not to mention 3-ring binders.
Up until probably just in recent history, most binders were very plain, very boring, had no style to them at all. The traditional market of office consumption is pretty boring, actually. The bestseller today continues to be black.
As offices got busier, mishaps were bound to occur. This engineer, named Richard Drew, working for the 3M company in the 1920s, made everyone's life easier when he got his hands on some new material called cellophane and invented Scotch tape.
When Richard Drew saw this material, he coated some adhesive on it, slid it into tape, and sent it to a company in Chicago that wanted to use it to wrap bakery goods. And in 1930, Scotch cellophane tape was born.
3M followed Scotch tape with the tape dispenser in 1932.
The response to Scotch cellophane tape was overwhelming for 3M. Introducing a product during the first year of the Depression would not be considered very good timing. 3M was one of the few companies not to lay off people during the Depression.
It didn't take long for Scotch tape to wend its way into offices, fixing torn pages and sealing envelopes. Today, the company produces over 900 different Scotch products.
Over 90% of the offices and households in America have a roll of Scotch tape.
Paper, pencils, and tape are crucial, though low-tech wonders. But at the height of the Industrial Revolution, 2 high-tech inventions would usher in the age of the modern office. Next, the telephone and the typewriter. Dallas Secretary Betty Nesmith, who invented liquid paper in 1956, is the mother of Michael Nesmith of the Monkees. Office Wonders will return on Modern Marvels. During the 19th century, people began to realize the value of time. Before this, things happened at a slower pace because they had to. We traveled at the speed of horse. Distant communication was slow and trade slower. Most offices conducted business with their neighbors. Time crept along unhurried. Then came the railroads. People could ship products further, faster, and to more customers. The better you made use of time, the more products you sold, and the more money you earned. Efficiency became the name of the game. Along came the telegraph, and people conducted business by electricity, wiring orders for goods in a matter of hours. The more you sold, the more paperwork you needed to process. Enter the typewriter.
The typewriter was invented at a time when the American factory system was really building steam. There were consumer goods being churned out of America's factories at a tremendous rate. But in the front office, there was a huge backlog because all the paperwork that went along with the products was done by hand. So American industry needed the typewriter to do the paperwork to keep up with what the factories were churning out.
Christopher Latham Sholes, an inventor from Milwaukee, produced the Sholes and Glidden typewriter, which went on the market in 1874. The concept was simple. You press a button linked to a lever which causes an arm to swing up and whack against an inked ribbon in front of a piece of paper.
This was the first typewriter. It is decorated with Victorian floral decals and gold curlicues, but there's no mistake. It is a typewriter, and it is the machine from which all modern typewriters evolved.
Within 5 years, most of the bugs had been worked out, and out came a second model.
The Remington No. 2 was really a perfected machine. It was eventually very successful, and it really became the archetype of old typewriters. Big black box with keys.
Typewriters epitomized the spirit of invention that swept late 19th century industrial America.
The real challenge in building a typewriter was achieving precision, because you had hundreds of parts that all had to work together to print a character on the page, space it one character down for the next one, type uniform straight lines.
Typewriters helped people standardize and streamline. For instance, the 8.5 by 11-inch sheet of paper used for business correspondence was established by the typewriter. And carbon copy invoices were more legible when they were typed rather than handwritten. Soon, typewriters began streamlining too, and adding improvements. The shift key provided access both to upper and lowercase letters, thus twice as many characters. The keyboard was laid out in what's called a QWERTY keyboard, keeping common pairs of letters apart and preventing the typewriter arms from rubbing and sticking together. The tab key arrived in the 1890s, allowing columns for numbers and counting.
In 1895, the Underwood came out. That was a typewriter in which the type bars struck the platen from the front. You could actually see what you were doing. The Underwood was the first modern typewriter.
Some features were there from the start, setting margins, for instance, and the ubiquitous little bell that warns you when you're about to type off the paper. It's now a cultural fixture. Innovations would follow. A portable model showed up in 1884. An electric one in 1902. Electricity being scarce in 1902, it didn't really wow the business world. It was left to a time clock and punch card sorting company called IBM to make the first successful electric model in 1933. In 1961, they wowed business again with their Selectric typewriter.
The IBM Selectric was a groundbreaking typewriter. You had a machine in which the carriage did not move. The element moved side to side, and this little ball danced along the paper. It was wonderful to watch. It worked beautifully.
Typewriter manufacturers introduced another office in innovation, the female.
The first makers of the typewriter, the Remington Company, actively recruited women to learn how to use the machine so that they could be hired as operators of the machine. This brought women into the office world, which previously had been an all-male environment.
One of the advantages of women workers was that they were cheaper to hire than men.
A lot of women were deliberately paid less because the attitude was, well, they're living at home, they're not supporting a family, therefore they don't need the money, and they have a father to help them out. And even if the woman was a single independent woman, they were still scrambling to get by.
Women would be impacted by another great 19th century office wonder, Alexander Graham Bell's telephone.
When you speak into the telephone, the transmitter takes your sound waves and converts them into electrical waves, if you will, into an analog, a waveform that has the same shape as the sound waves but is an electrical wave. This electrical wave can then travel down a wire in the simplest of telephones to another telephone, where the receiver will take that signal and convert it back into a sound wave, which you can hold up to your ear and hear.
Phones were introduced in 1876, marketed in 1877, and by 1878 there was a need for the first central switchboard run by operators. Women would largely make up the workforce of telephone operators as the revolutionary device took offices by storm.
The men who actually ran the telephone industry in the early days saw the telephone preeminently as a business tool. From the first, there were both business and residential subscribers. But even in the marketing to residential customers, the emphasis was on the business use.
And businesses bought telephones like hotcakes.
The first telephone directory in New York City, and it's primarily business customers, fit on a single sheet of paper. By the directory for 1900, you're dealing with a fat book of almost 600 pages.
By the 1890s, desk models appeared, which were standardized into the familiar candlestick phone by the turn of the century. Multiple line phones appeared in 1892. Sub-switchboards called private branch exchanges, or PBXs, appeared in the 1890s. Office buildings could now have a local network.
AT&T itself, American Telephone and Telegraph Company name, first appears in 1885. It was incorporated specifically to build and operate the first long-distance network in the United States. It started construction in New York, building out in every direction, and reached its initial goal, Chicago, in 1892.
Long-distance calls were nearly all business-related due to the cost. $9 allowed New York to speak with Chicago for a minute in 1892, which is the equivalent of about $100 in today's money.
Similarly, when long-distance service became available from the Atlantic to the Pacific, the initial rate was $20.70. With such prices, calls tended to be made for those uses where the financial benefits were commensurate with the cost.
But for business, instantaneous communication was worth it.
The telephone made it possible to more closely coordinate economic activities, business activities occurring in different places than any previous device. There are some advertising brochures that AT&T put out in the 1890s. On them it says, the mail is quick, the telegraph is quicker, but the telephone is instantaneous and you don't have to wait for an answer. It's interactive. And businesses seized on this.
In 1927, North America and Europe could talk for $25 a minute. Other crucial business innovations included the hold button and key sets with extra rows of buttons for tailored office tasks. Mobile phone service began in St. Louis in 1946. Speakerphones arrived in the 1950s. and touch-tone service in 1963. Toll-free 800 numbers soon followed.
AT&T introduced the first answering machines in 1953, marketed just towards business customers. Another innovation is older than people think and was primarily used by businesses in the early days were telephone credit cards. AT&T introduced the telephone credit card in 1939, and it was designed for people like traveling salesmen who'd have frequent needs to call home from the road.
The telephone allows businesses to run at the speed of sound. Today, it is unimaginable to think of an office without a telephone, just as it is unimaginable to think of an office without a copying machine. But it took clever marketing on the part of a little company called Xerox to convince businesses that they would ever need to make hundreds of copies of the same sheet of paper. Next, all about facsimiles and copies. Alexander Graham Bell's cousin, Chichester Bell, was an early patent holder in 1886 of an office dictation machine that would become the dictaphone. Office Wonders will return on Modern Marvels. By the 1920s and 30s, offices were becoming models of efficiency. Uniformity was key. The parts of the office were like interchangeable cogs in a great machine. If a cog or a worker broke, another identical one could be put in the same place.
If you think about the design of offices, there is a little parallel here to the design of early factories. When the factories first started appearing, they were designed to get the maximum use of the machine. So forget the human operatives. Who cared about them? Plenty more where they came from.
Huge office buildings had rows and rows of identical desks and lamps and workers behind them. Every once in a while, someone would jump out the window. But other than that, it seemed to work. What the office lacked in personality, it made up for in efficiency. It seems natural for office managers to take advantage of a machine that could duplicate documents exactly, but they didn't. First of all, carbon copies existed. But carbon copies could only make 3 or 4 copies at best, and they were hard to deal with. But a little company named Haloid was about to change everything.
The Haloid company started here in Rochester, very, very small company, actually in competition with Eastman Kodak. And they started to search for new product. And they were looking for something new and different for the future.
They found it with a lawyer named Chester Carlson.
He actually was educated as a physicist. Now, back in the early 30s, he, as a patent attorney, had to make copies, and he was very dissatisfied with what was available. So he actually started out saying, I'm not going to use chemicals. I want to use some physical principles because I'm aware of physics. And he started the early work on what we call electrostatic printing.
Electrostatic printing would become xerography, from the Greek words for dry and writing. Basically, a light passes over an image placed on photoconductive material, increasing the electrical conductivity of that material. The pattern can then be repeated on another surface when a powder is passed over that surface, clinging to the charged portions. The first demonstration of this phenomenon took place on October 22, 1938, in Astoria, Queens, New York. But Carlson had trouble convincing others of xerography's potential.
He was a lousy salesman, and he went out in the countryside, actually visited 27 companies, including IBM, Eastman Kodak, Bell and Howell. He went to everybody trying to sell them on the idea of xerography, and nobody was interested.
Nobody, that is, except for Haloid, which spent the next few years turning Carlson's ideas into a working machine.
First true copy that made copying easy was the Xerox 914. It was announced in October of 1959. First machine was delivered in March 1960. Enabled somebody to put an original in platinum glass, dial in the number of copies they want, press the button, and they were finished. The copies came out.
Haloid built it, but did anyone really want it? The company was running out of money and started searching for a partner with deep pockets. They approached IBM.
Now, IBM went to Arthur D. Little, very, very fine market research outfit, and said to Arthur D. Little, do you think there's a market for this machine? And Arthur D. Little went out and did a market research, and they came back and said 5,000 units will saturate the market. There was a big meeting at the Haloid Company, and we decided to go ahead on our own. Now, we went ahead spending money we didn't have for a product that nobody wanted. If Harvard Business School studied this thing, they'd say that was a course for disaster, that you guys were going down the wrong alleyway, and it was pretty stupid.
But Haloid had a plan. They would rent out the 914 for $95 a month, even though each machine cost over $2,000 to manufacture. Each customer would get 2,000 free copies each month, with subsequent copies charged at 5 cents apiece. Much to everyone's surprise, businesses went copy crazy. They copied memos, invoices, articles, recipes, cartoons. Over the next few years, Haloid focused on xerography, and rechristened Xerox produced over 200,000 914s.
We calculate that over 600,000 placements were made of the 914 during its lifetime. And this is the machine that Arthur D. Little said 5,000 would saturate the market. How successful was it? According to Fortune magazine, probably the hottest return on investment of any commercial product.
Today, copiers are faster, more reliable, and studded with features, including collating, stapling, enlarging and reducing, image rotation, and color. The product that nobody wanted is now indispensable. Though other companies now make copiers, the name Xerox is synonymous with copying.
Copiers change the office environment in really one fundamental way, and that's communication. Prior to the office copier, communication was very difficult in the office. And that really was the change that the copier brought to corporate America and then on a worldwide basis. Today it improves workflow, it improves productivity of everyone.
Now, if only you could take a page and send a copy of it somehow, instantaneously to someone far away, that would be impressive. Scotsman Alexander Bain thought so in 1842 when he invented the first facsimile machine using old clock parts and electrically conductive paper. It was a workable machine, but since it predated the telegraph and the telephone and their electrical high wires, Bain's machine drifted into oblivion. Years later, and quite independently, Elijah Gray in this country tried his hand at the fax machine, creating the telautograph, which used a stylus connected to a metal plate. Much like the telephone and the telegraph, a signal generated by the stylus is translated into an analog and sent along wires electrically, then reconstructed at the other end into a facsimile of the original image. These early machines began turning up in banks, hotels, and even racetracks. Eventually, Elisha Gray's telautograph company became Omnifax, which produced more modern facsimile machines in the 1960s. By the 70s and 80s, the familiar fax became a phenomenon as the machines began chirping like birds to each other all over the world.
There's a handshake that takes place before the transmission actually happens to establish compatibility between the two units.
In the late 1990s, Xerox bought Omnifax and began rethinking the fax machine's purpose as office equipment.
When you think about it, a fax machine really consists of a printer, just like any other printer, consists of a scanner, just like any other scanner, and then some control electronics and communications electronics to tie the pieces together and to make them work over a telephone line. And when you put a scanner and printer together, you have a copy machine as well. So you can put all those pieces together in a very effective machine.
Carlson, Bain, and Gray probably didn't envision that as they toiled away in their labs, nor did they likely envision a device that threatened to make all their revolutionary ideas, even paper itself, obsolete. Next, the personal computer. Consumers spend nearly $900 million annually on ballpoint pens, though most individuals borrow theirs from the office supply cabinet. Modern marvels will return. The modern computer began so innocently as a way to quickly count heads. All the heads in the whole country. Census takers took forever to analyze the information they got from their statistics. By the time they figured it all out, it was time to start the count all over again. There had to be a better way. But there wasn't. Not yet, anyway. Census takers needed some sort of tabulating machine that would speed the process up.
And to do that, they would need some form of data or some way of collecting the information. So they created some cards that could have holes punched in them. And they created a tabulating machine which would take these cards and tabulate the results.
If tabulating machines or calculators could count heads, maybe they could figure other things.
The first real machine built was by the U.S. Army to do ballistics calculations, to try and assist in improving artillery tables based upon wind and weather and things like that. So it was a way to alleviate and speed up computation when you need it. So the initial intent was numeric applications.
These were no pocket calculators.
Some of them, like the ENIAC, for example, was 100 feet long, 10 feet wide, several feet high. The early machines had 18,000 vacuum tubes in them. They weighed tons and used 200,000 watts of power. So they were very large, and surprisingly enough, not more than, say, a few times faster than a human being could do the addition.
Each computer would have to be instructed or programmed to do a specified task.
Basically, a computer is some electronic circuits who only care about being on or off. And therefore, you send it a list of instructions that tell a series of circuits to be on or off. You can do numerical calculations just using 1 and 0. It's a binary arithmetic system. And computers basically are capable today of doing 1s and 0s, and the instructions tell it how you want those and in what pattern, and that basically allows it to be very functional, have a wide variety of things that it can do based only upon those instructions that you send it.
Hence the punch cards, with holes triggering circuits to turn on or off. Punch cards were in fact the first software.
Software is basically the instruction stream that makes the computer do what you want it to do. It's interesting because you can make the computer do it either crudely or elegantly, and so software is both art and science in the way that it comes together.
Business soon saw office applications for the calculating tabulators and began incorporating them into offices, often to handle payroll functions. The problem was, these early machines were the size of offices. Computers began replacing their thousands of vacuum tubes with transistors in the 1950s, becoming smaller and more energy efficient in the process. Integrated circuits and microchips shrunk the computer even smaller. Soon they could fit neatly on the top of a desk. Born in the 60s, the personal computer began reaching into offices in the 1970s, and suddenly offices were moving at the speed of light.
The computer completely automated the ability to generate documents, so by editing, it would then allow you to reprint the document without the serious labor of having someone have to re-keystroke every single thing.
Change fonts, shuffle paragraphs, correct mistakes. Goodbye, typewriter.
Almost all of the functions of the typewriter have now been replaced by the computer. You can even take a computer and use a font which looks like an old typewriter and print a letter.
The days of the old punch cards are gone, and software disks with complicated programs are downloaded into our computers, allowing us to do word processing and spreadsheets with a click of a mouse.
Communication has been greatly speeded up. I think it's really wonderful to see people send a message out and within 30 seconds get a message back from someone across the country.
Now, just like phones, computers can talk to each other using local networks, providing instant access to all kinds of electronic information.
The computer gradually develops a digital nervous system in which they're all connected to each other and they can communicate all the time.
Not just all the computers in an office, but all the computers in the world. Welcome to the Internet, which began as a way for government research organizations to share information. Now it's a way to trade stocks, send memos, buy compact discs, or auction off a vintage vacuum tube. And computers keep getting better and better, more powerful and capable, faster and faster.
It's been a mistake in the past to bet against the hardware. That's always been wrong, and therefore there is no reason to suspect that we should bet against the hardware in the future. Transistors will get faster, they will get more dense, and we'll be more limited by our creativity than by what the technology will allow us to do.
Today's office flies along in warp drive, and therein lies a problem. Our brains can't go that fast.
Well, if you take me, for example, I still tend to write at least the initial first draft of what I'm doing longhand on paper, and then I use a computer to edit, because my brain works as fast as my hand, and I find that this is the best way of keeping my thoughts in order without losing track of the main theme.
Ignoring predictions of its demise, paper hasn't quite left us, despite the proliferation of electronic documents. In fact, we're producing more paper now than we ever did.
We need paper much more in the computer age. Think about it. Look how many times you print out your email, or you want to issue documents or pamphlets that go out, or the books. There's never been more books than there are today. And you can't take your computer into the bathtub to read it. You can't take it on the bus. The majority of people don't have laptops. So paper is still a very viable part of our economy and our culture.
Great. Information bombards us so quickly that our offices will have to figure out how to staunch the flow and sort it all out, just to get anything done. Carpal tunnel syndrome, an inflammation of tendons in the hand and wrist that afflicts 15% of high-risk professionals, is aggravated by repetitive acts, like typing. Office Wonders will return on Modern Marvels. Not all office innovation is the product of complex technology. In fact, innovations in paper continue. And like many breakthroughs, it's hard to gauge the need until the product gets out there. Take 3M's Post-it note.
One of our researchers in Central Research, Dr. Spence Silver, made samples of new adhesive that didn't stick very tightly. And when I was singing in the church choir in the early 70s, I decided that what I needed was a bookmark that would stick lightly, that wouldn't fall out between Wednesday choir practice and time to sing.
Fry decided he was onto something with his sticky bookmark.
Here are some samples of the very first Post-it notes that I made. And I made them in these colors and in yellow. And these were the first ones that we sold were in yellow.
Of course, before they were invented, no one realized they needed Post-it notes.
You have to create a market that hasn't existed before and show the customers why they need to use those products.
The public got the message on Post-it notes pretty fast. 3M now has over 90 different Post-it products, including computer applications.
It's a very effective, succinct piece of communication. People are forced to really shrink their message down to fit the note, so we get rid of all the unwieldy words that aren't necessary to get your message through.
Who'd have thought that communicating less would be an office survival technique? Computers and the internet are an Alaskan pipeline of information, flooding our cubicles, piling up on our stacks of memorandums and faxes and copies. Traditional offices are ill-equipped to handle it.
One has to wonder also, well, a lot of this work may or may not be useful work. Is it adding to anything? And the person who's doing it, of course, is going to say, well, it's very useful, valuable work. No one is going to say I'm doing something that doesn't need to be done.
Offices are finding new ways to deal with the tide of information.
There'll be a wide variety of new devices that will come out. These devices will take the place of telephones as they exist today on the wall or on the desk. Maybe they'll be in your microwave oven. Maybe they'll be on your refrigerator door. Maybe you'll step into your automobile and while you're driving to work, talk to someone through a very easy-to-use interface without having to hold something in your hand. Devices in the future will no longer look exactly like the standard telephone we know of today, nor will they look like the standard computer that we use today. They'll be adapted to fit the way you're used to working or the way you're used to living.
How about telephones that automatically route your business calls to whatever phone you're nearest, even if you're 1,000 miles from your office, just by punching in a code? Video conferencing, in which multiple cameras home in on whoever's talking.
Now, if you could fast forward in the future, wouldn't it be nice to have not just a two-dimensional representation of the people from the far end, but more of a three-dimensional representation? And holography in the future may be the way that we communicate not just a flat image of a person, but a three-dimensional image of a person that is part of a video conference. Maybe they'll call it a holoconference.
Imagine having a conference with someone who isn't really there. How about having it in an office that doesn't exist? Jennifer Johnson runs a marketing firm called Johnson & Company with 16 employees from a virtual office.
We have our corporate headquarters on the internet as opposed to any bricks and mortar facility. In fact, when people ask me, when you get bigger, are you going to want to have a physical office? I'd view that as a step backwards. What we do is give people the opportunity and ultimate flexibility to work out of their own homes, to determine their hours, how they want to get their work done, when they want to get it done.
Johnson's co-workers connect and communicate, strategizing for clients, analyzing data, and doing market research across 4 time zones, through the phone and the internet. Johnson can review a memo in California at 11 and instantly send it to co-worker Jordan Karpowitz at her apartment in New Jersey at 2.
We do have our sights set, though, on going international. I've had dialogues with companies in Europe and even Asia, because to me it would be so exciting for a 100% virtual company to be able to offer global services.
But what about those people still working in the brick and mortar buildings?
There will always be some sort of office, some sort of central place where people can go, because after all, human beings are social animals. We do learn from each other, we interact with each other. The office is a place of work as well as a place of social interaction. So yes, I think that there will always be an office.
Those brick and mortar guys are finding ways to innovate too. Take John Ferrara, who runs a software company called Goldmine. Goldmine makes a software application that works like an electronic scheduler, coordinating and interconnecting the workday priorities and plans of everybody in an office, plus clients.
It ties people together so that they can all keep track of the relationships, what's pending, who's going to do it, and what's been done.
Not surprisingly, this cutting-edge software company takes a new approach to the traditional office dynamic. They want their employees to be more than just parts in the machine that is the office. They want them to be happy. Goldmine thinks happy workers are more productive ones. This is not your father's office. This is a whole new way to get the message out, to communicate, and it always goes back to communication. That's what an office is all about. And that's what all this technology is supposed to do. But it can be overwhelming. Sometimes you need to step back from it all.
That's why we have the office here at the beach. That's why we have benefits that enable people to go to the gym and work out in the morning or at lunch, or go to the beach and run on the beach, or surf in the morning or in the afternoon after work.
I work from 7 to 4 just so I can get off at 4 and surf until dark.
high-tech software company with an office on the curl of a wave. Surfing the net 1 minute, surfing the Pacific the next. All of these high-tech marvels just might help us busy bees get a bit more low-tech with our hectic lives. The office of the future is a pretty exciting place when you think about it. Almost makes you look forward to going in tomorrow. Almost.
Former U.S. Marine, drill instructor, Vietnam veteran. Now he's facing his greatest challenge. Your question.
What does GI stand for? What kind of grabastic, unorganized question is that?
Join R. Lee Ermey.
Can it, numbnuts! Now listen up. Want to know how to drive a tank? How a gas mask works? What dog tags are used for? I know all the answers, so ask the questions, maggot!
Mail call, Sunday nights at 10 on the History Channel. Ask at your own risk.
Now an exclusive offer from the History Channel. You can own the program you've just seen on video cassette for only $24.95 plus shipping and handling. To order, call 1-800-708-1776 or shop online at historychannel.com.